Looking at the attendee list here, there's a handful of friendly faces, so I'm glad to see those on here. Well, we're going to get started. As Alicia mentioned, if you have any questions, throw them into the Q&A block. I've got a lot to go over in this hour we have together, but she'll catalog those and we'll go over them at the tail end. So just real quick, what we're going to try to cover today is just a real brief overview of the problems facing healthcare. We're going to go over the concepts of network behavioral anomaly detection and how they apply to these problems, protecting crown jewels, specifically things that are in scope for PCI, HIPAA, research data, and the rest, the information inside of healthcare that's being targeted for theft, and how NBAD approach can address some of those concerns. Handling the diverse types of insiders interacting with the networks and data inside of healthcare. And we'll also take a little overview on audit trails and that importance as far as response, as far as responding to threats. And if time permitting, we'll go over the StealthWatch product architecture. So real quick on the problem description. The things that we know are being stolen are credit cards and patient records. There was a report from Gemalto put out recently, the 2014 breach report, and reading from it, as picked it up this morning or read it this morning, it says, no industry has experienced as many data breaches as the healthcare sector, which had 391 breaches in 2014. That amounted to 1/4 of all the breaches. And we'll talk about why that's true, but part of it is there's a lot of credit card information, and credit cards are selling between $4 and $12 in the black market. Don't really need to go into why that's lucrative. But patient records, you can use them for everything from taking out loans, creating new credit cards, all those things attached to financial gain for criminals, but also more clandestine uses, such as getting across borders you shouldn't be getting across, and the rest. And so healthcare has become probably the primary target for that type of theft. There's a couple of other areas that we're seeing indicators of risk. I personally have not seen a viable, confirmed report of any of these things in the wild. I've seen indicators that they may be happening, but nothing closed-looped and conclusive. But there is a risk of terrorism via equipment manipulation. If you remember with the Dick Cheney pacemaker issue, there was an exploit against a pacemaker which posed a risk to the previous vice president, who basically had to have his pacemaker patched because he could be remotely killed, right? It's the scariest way of framing that type of problem, right? But things are connected in the Internet of Things broadly, but very specifically inside of healthcare, we see things like defibrillators, monitors, MRIs. Everything is just ultra-connected, which could be used for ideologically driven attacks, terrorism, those types of things. There's also some indicators that nation states are targeting healthcare for trade secret information. That much we're pretty certain that's happened. And going back as far as the Mandiant APT1 report, there were documented cases from Mandiant on attacks against healthcare for stealing research information. There's also some indicators that nation-state attackers are trying to collect patient information as well. So again, these are things that are very likely happening, but we're not very good at catching them as an industry yet. So who are we talking about as far as who are the bad guys in this? We have activists. Activists haven't targeted healthcare as much as organized crime. Organized crime, there's Al Capone. I'm dialing in from Chicago today, so he's my organized crime icon. But organized crime or criminals have been driving almost all of the attacks that we have caught in healthcare. And the reason is for money, right? They're motivated by financial gain and credit card records, and patient records are great ways of cashing in. But activism, goes well beyond just the anonymous. Anonymous is trying to open up information. They don't want information hidden. They don't want monitoring, is best I can tell, their primary ideology. But we do see things that are on the national stage, like the ISIS and other terrorist organizations that have a different ideology that may be motivated to, at some point, attack healthcare. Nation states, we also mentioned, they have geopolitical concerns. They want their nation to be greater than other nations. They want the companies to have an advantage over the companies in other geographical locations. And then there's the insider, and that's actually the picture of my boss. That's one of the nicest guys in the world, Tom Kennedy. But if I put my picture up there as the insider, I look like a threat, so needed someone a little bit softer. But the insider has all kinds of diverse reasons to exploit and harm the organization, and we'll look at that in depth here in a bit. So we have something to steal, we have people trying to steal it, and exasperating this is actually pretty easy to steal from. It's pretty easy to steal from healthcare, and there's a couple of vulnerabilities I want to hit on. One of them is that there's been a poor investment in InfoSec over the history of IT and healthcare. That's true in general across all against all markets, but all verticals. But in healthcare, it's been especially true. Very few healthcare organizations had a full-time security operations center or incident response team, and quite frankly, even documented processes when something goes wrong. What do we do when there's even a virus infection, or what do we do if data is documented as being stolen or detected as being stolen? And so there's been an even further lag in healthcare over time, which made it very easy, not very easy, much easier to exploit than other verticals potentially. There's also a desire to spend money on the core competency of healthcare, which is helping and saving and improving lives. So if there's money left over, it's difficult to move that away from research and development and to further the business to help patients and healthcare providers and the rest in doing their business, to put it on security. So that's an issue, and as a side effect of all that, a lot of the technology that we see in healthcare is dated and needs to be replaced, upgraded. So all those things systematically, which we see across all verticals, are exacerbated across healthcare. And the second one is, it's very hard, it's complicated in healthcare. In many enterprise organizations, you have IP phones, you have computers, PCs, workstation types of things, laptops, tablets, and servers, and that's it. In healthcare, virtually everything inside of a hospital or a research facility is networked. If it's healthcare manufacturing, the production gear is on the network. Inside of a hospital, you have the defibrillators, the MRIs, the X-ray machines. There are just so many different types of devices that building secure networks, both for monitoring and protecting them, have a wide range of complexities. There's also a desire to do things like cure cancer and save people's lives, and to collaborate on that. And there's a timeliness to it. There's a need to do that quickly, a desire to innovate. And so there's a lot of things coming onto the networks. There's a lot of changes that have to occur quickly. And because of those external pressures, less secure devices make it onto the networks. We also have the challenge of, currently with Windows XP going end of support, and a lot of these devices are built on that technology, so replacing those are also a part of it. And another part of the complexity puzzle is the diverse number of users or use cases. You have financial folks, like everyone does. We also have doctors, we have technicians, we have receptionists, we have consultants, we have contractors, we have patients, we have patients' families, we have folks providing service inside of these facilities. We have insurance underwriters. We have people writing programs. We have research. There are so many use cases that the complexity in almost every healthcare industry and every organization is much more cumbersome than in your standard enterprise network environment. So that's the problem description. Let's go a little bit over network behavioral anomaly detection. NBAD, or network behavioral anomaly detection, is a way for looking for threats inside of the network. It's a metric or quantity-based approach to doing IDS. We're not really as concerned with what's inside of a packet. We're concerned about how many of those types of packets are there. How much email traffic do we normally have? When things begin to deviate from known good patterns, or we start seeing known bad patterns, that's when NBAD is going to trigger. And as a result of that, network metadata like NetFlow became a really good source because it has those numbers that we need inside of it. And it essentially allows us to convert the whole network into a sensor, not just looking at choke points of traffic, but really focusing on internal-to-internal conversations, like why are the MRI machines talking to the credit card processing machines? That makes no sense. That's not a normal thing to happen. And we can observe that because we're using the network as a sensor by leveraging the NetFlow coming out of it. It allows us to look deeper. So that said, there's often market confusion over NBAD because NBAD uses NetFlow as a feature. It doesn't have to. We can use probes just like any other IDS. But because we use NetFlow and rely primarily on NetFlow, other NetFlow tools sometimes get thrown into that mix. Just real quick on NetFlow, if you haven't gotten up to speed on it, it's just a metadata record. Down at the bottom, we have a quick example of, at this time, across this interface, this IP address from this port, talk to this IP address on this port over TCP, 2 packet sent, byte sent. So it's a metadata log of a conversation. The most recent, Cisco invented NetFlow. NetFlow is a category covering all of these types of logging, metadata logging. It's also a specific format that Cisco developed, and NetFlow version 9 is in an informational RFC 3950. IPFix, which is sort of the global standard for anyone wanting to do this type of metadata, is in RFC 5101. And so sometimes you'll hear Juniper, sometimes as JFlow or CFlow-D, we've heard NetStream, RFlow. Many of those things from a packet capture perspective are in this grouping called NetFlow or network metadata. So as far as the analysis goes inside of NBAD, or really any type of detection, those of you that have been on my webinars before or know me from the past know that I spent some period of time working for the InfoWorld Test Center testing network security stuff back around 2004 to 2008. And we started breaking up how do things detect threats. Normally when we talk about intrusion detection or threat detection, we are most comfortable thinking about that in the context of signature-based detection. And that's really where an object, a file, or a packet is the object, and it's entering the victim or the subject. So in the case of antivirus is inspecting the file as it's entering the target, the subject, which is the computer. IPS focuses on the packets, looking for known bad patterns. So the great thing about signature-based detection is it is very reliable at catching known threats. It can document what to do. So if you see a packet coming in that's associated with a certain SQL injection, you can list all the references. This is a SQL injection attached to CVE, XYZ, whatever it would be. And then you can deal with it. You have a high degree of understanding, assuming you have enough data to match the pattern. Behavioral-based detection is looking for what the subject does or the victim does after it ingests the object. So by favorite example of this really is the cupbearer, in ancient times, right? If you wanted to inspect wine for poison, you could do, a molecular analysis of the thing, look for mold or smells or some kind of characteristic that you knew to look for. That would be signature-based detection. Behavioral-based detection is you give the wine to their cupbearer the wine, he drinks it, and then the king looks at him. If the guy starts foaming at the mouth or kills over dead or becomes nauseous, those are behaviors that are known bad behaviors, and you're able to connect that known bad behavior to the object that was ingested. So things like sandboxing, like from a FireAmp or FireEye, those things, what they do is they take in the file, they execute it in a sandbox, and they watch for bad behaviors like deleting files, trying to communicate out of the network, reading address books, all those things. So again, it's watching the victim after the object is ingested for known bad behaviors. And from a in-bad perspective, that's looking for things like scanning the network, using protocols they shouldn't be using, breaking network segmentation, and we'll go over some more examples of that along the way. Anomaly-based detection is very similar to behavioral-based detection, but instead of looking for known bad behaviors, you're looking for deviation from known good behaviors. So an example of this would be if someone shows up to work every day at 7:30 on time and has done that for 10 years, and then they show up at noon. That's a little weird. That's a little anomalous. It's deviating from what is established as from normal. And of course, if he doesn't show up for a week, it's extremely anomalous. And if he shows up, I'm going to skip that joke. It never works. Okay. But that's anomaly detection. Again, you baseline what is normal, and then you look for deviations in that. So signature-based detection is fantastic at catching known exploits. Behavioral-based detection is very effective in catching zero-day exploits. It means you don't know what the poison is, but you know what's going to happen after the poison is ingested. Right? It's going to start scanning the network. There are certain things you know what to look for, so you don't need to know what the attack is. You know what the payload or compromise actions are going to be afterwards. And then anomaly-based detection is good at catching things that leave no marks. Like if you look at the Edward Snowden event, Booz Allen hired him to work inside of the NSA. He was given access to the servers at the NSA. He had to communicate with those servers to execute the duties he was paid to do. But there was some pattern that's normal for Booz Allen administrators to access data on. What he did was outside of that normal. Maybe they collect 10 megs of data in a day and doing their information and doing their jobs. They probably don't collect a terabyte or more of information from diverse sources. So if you can establish mathematically what is normal, you can begin to calculate and alert when things move away from normal. But with behavioral detection and anomaly detection, one of the complexities is how weird does something have to be before you start alerting. Signature-based detection is very Boolean. It's black or white. It's red light or green light. It matched or it didn't. But when you're talking about things being weird, do you call the police when the guy shows up, when he's still not there at 9 o'clock in the morning, or do you wait a whole day? At what point is it sufficiently abnormal? And so the approach that I advocate and that Lancope uses in solving this is basically assigning an index or a series of indices to every entity that you're observing. In our case, it's hosts on the network or users on the network. And you start counting. If someone does something a little bit suspicious, you give them a few points of what we call concern index, or a few points of concern. If he does something radically abnormal or known bad, it's going to be a ton of points quickly. And then depending on the risk that host poses on the network, you will alert at a different threshold. So if a wireless user is just misbehaving on wireless, your threshold for pain, your alarming threshold will be higher than an in-scope PCI device. So that said, that's algorithmic detection inside of INBAD. And so with that said, let's look at some applications inside of healthcare with NBAD. The first is really doing what I call protecting the crown jewels, and every organization have different jewels to protect, but they could be the cardholder data, patient records, trade secrets, M&A information, research data, state secrets. It could be compromising those bio devices and harming patients. But really, it's the data that you can't lose. It's your protected data that needs to not fall into nefarious hands. So we've gone over some of this a little bit, but criminals want the PCI data, the card data, the patient records for the money. Activists want to do some shaming or have a conversation. As Edward Snowden's a good example of that, he wanted to expose the NSA and their data collection issues. State-sponsored, we've already gone over some of this information in other slides. And so when you're trying to protect crown jewels, you're talking about things that are inside the network, and you have people inside the network that can access that information, whether they are researchers or doctors or patients or any of those folks. It's inside conversations, as we saw with Edward Snowden, who just walked out of the door, pulled it off the network, put it in his pocket, and walked out the door. So the first thing that we do, there's a concept in NBAD called enclaving, which we just call host groups inside of StealthWatch. But the idea here is we group things that are like each other. So in this case, where I have crown jewels, this is where the information is. This is a grouping of all of the hosts on the network that have that protected data on it. These are the machines that are supposed to access that information. So in the case of PCI, this would be the thing processing and storing credit card information. These would be the POS machines. And these are patch management servers and things that are providing some level of support to these things that are in scope. So inside of StealthWatch, it's pretty easy to set up. We have a bi-data tree. We talk about what kind of data it is. And there may be multiple levels of this. It might be administrative access. It might be executive access, and so forth, whatever makes sense inside of the organization. And then going to anomaly detection, we have counters that are counting specific things. So in this case, we have a counter called data loss. We monitor every host in the network and count how many bytes that host sends out of the network. And then we look at his peers, in this case, desktop machines that are crown jewels authorized Windows machines in Chicago, and we mathematically calculate what's normal, how many bytes are normally sent out of the network. And when Barron's machine, this IP address, sends a mathematically excessive amount of information out of the network, this alarm is triggered. Suspect data hoarding is very similar. But instead of sending information out of the network, to the internet, this is someone collecting a lot of information. So I see this all the time, particularly when people are quitting. They go and they download customer information, research data. They just collect it to their machine, to their laptop. They put it on a thumb drive, and they walk out the door with it. This is what Edward Snowden did. He went around the whole network and started collecting internal-to-internal data. We call that SDH, or suspect data hoarding, but it's a great indicator of an insider abusing their credentials, and we'll talk about this in a bit, but on the insider threat piece. But monitoring what is the normal expected amount of data to be collected, and when someone exceeds that, we're going to trigger these types of alerts. We also look at things like relationships altogether, not just the individual hosts, but what happens when all of the administrators start doing something weird collectively. These types of workflows are particularly interesting when many assets inside the network become compromised, when you have an attack that compromises one machine, multiple machines, and then they act in concert to quickly collect and exfiltrate data in a way, a distributed type of exfiltration. So we look at things on a host level, we look at them on a user level, and we also look at them collectively as peers. There is no one normal inside of any network. That's true inside of healthcare, and as we discussed earlier, there are many types of scopes. There are many types of normals inside of any organization, and one healthcare organization down the street is going to have a different set of normals than their counterparts down the road. So the idea behind NBAD is you have to have the context and specific monitoring around the tightest possible scope. So, for instance, this is where the data is. This is where the authorized machines are. At Lancope, we're a software company, and our crown jewels are our source codes, the source code. Our programmers are the guys that are authorized to access the source code, and if they don't do that, we don't get to have the next cool release of StealthWatch. But there is a normal amount of access for our programmers in accessing both putting data up and pulling data down. And so we monitor for normal types of conversations. If someone tries to pull down all of the source code, we're going to tackle them to the ground, right? That's a very anomalous, unnecessary abuse of credentials. We can also validate that segmentation is working. For instance, there should never be any communications between these crown jewels going to the internet. It should never happen, either coming from the internet to these machines or from these machines going out. And I worked with a customer. I was sleeping in Minneapolis one night over in St. Louis Park, and at 3 o'clock in the morning, my phone's blowing up, and I roll over and say, what is going on? Come to find out that data was leaving a highly protected network segment, and that segment had petabytes worth of patient records on them, and were leaving the network going to Asia. And of course, it's a very scary event. It's waking them up. It's waking me up. And but it should, in their words, it should be impossible, because they had several levels of segmentation that prevented data from routing except to a couple of authorized segments like these. Well, as we're doing the investigation, we found that credentials were stolen. Those credentials were then used to compromise the machine. That machine was then used to also use the credentials to create new routes. There were L2TP tunnels or VPN tunnels created between those protected segments and the attackers. And so they were exfiltrating data over that secure socket. So there was, we really didn't need a whole lot of anomaly detection to see this should never happen. This line should always be dark. The threshold for this is 0. Anything above 0 wakes people up. So we can validate that enforcement mechanisms are working from a logical perspective. So we don't care what interfaces are being routed across, right? We're not monitoring from an interface perspective. All we're saying is, this is the internet, this is a protected data, none shall pass here. If anything ever moves, I don't care how it gets from point A to point B, start waking folks up. And so what we end up having, as of StealthWatch 6.5, we start making these basically signature-based checks. There's a segmentation violation between the crown jewels authorized to a server it should not be talking to. And so anytime segmentation or scope is broken, that can be alerted. And it doesn't have to be internal to external. It can be internal to internal. And so very important to validate and monitor that the enforcement that we've built is actually working. So in talking about insider threats, this is really the sweet spot for Lancope and the sweet spot for NBAD in general. There's no log entry when Edward Snowden logs into a machine. If you have an insider that is abusing his privilege, there's no log to that, at least no actionable log. You don't alert on that. And so just real quick, this is I did a webinar a few weeks ago, I think, I don't know, it was recently, on insider threats. This is a subset of this I just want to go over, but a few points. When we talk about insider, we have the actual human being. We have Tom Kennedy's smiling face. We have the credentials that are used to do what we call authentication, which is mapping this human being to a computer user account. And then the human being can't do that without an endpoint. We're very bad at speaking digital. We are very analog very analog entity. So the human being touches this thing, puts in credentials, and has access to the network. So when I talk about insider, it can only be any of these three things, right? If you can compromise a human being, that's the most valuable thing ever. If you actually have a human being walking around inside of a network that will do what you tell them to do, best exploit you can do as a hacker. Second to that is steal his credentials so that you can act on his behalf anywhere in the network that you want. And then lastly, if you can compromise his endpoint, the thing that is doing the math and moving the packets around on the person's behalf, that's also useful. So, and virtually, I'm not a huge statistic person. All of you on here know that there's a problem or you wouldn't be on this webinar. But credential abuse is what I normally call it when any of these things are abused. Is a part of every one of the major breaches that we read about. It is, and it's the hardest to catch. So real quick, I won't belabor this. We went into depth on this on the Insider Threat webinar, which is up on the website and YouTube. But there are a lot of ways to exploit my buddy Tom, right? Not him in particular, but insiders in general. If they're disgruntled with work, have an ideological problem, you recruit them. You encourage that difference. You feed off of that. If they have financial problems or they just want more money, give them more money in exchange for not showing up to work, writing down their credit card number. Not the credit card number, their password. I saw a disturbing statistic. I haven't validated it, but it was there was some survey done that for $150, 1 out of 7 employees interviewed would give up their username and password for someone else to use. So, and that's them admitting that. So anyway, it's a troubling idea. But even beyond that, if you're looking at financial, why spend $100,000 trying to break into a network if you can bribe somebody for $10,000? And you know, when I mentioned organized crime, I didn't call them cyber criminals because criminals can be any kind of criminal they want, and they can change instantly. You can easily go from being a cyber criminal to executing extortion or murder. There's no limit on that, and generally criminals don't feel boxed into one. Loneliness, of course, you become a friend, romance, love of family, you can kidnap their family. All these things are on the table. So all that to say, there's a lot of ways to get to the human being. When we look at stealing the credentials, this is where most of them come in, brute forcing passwords just because it's a weak password. Personal markers, we put up way too much information on the internet. If you wanted to research me, you could learn all kinds of things about me in probably 30 minutes because I just posted a video of scuba diving earlier this morning up on Facebook. You know, they've got a LinkedIn page. We put up way too much information, and that information can be extracted to create a custom dictionary for Charles. What's my wife's name? What's my birthday? What's her birthday? All these things are publicly available to create, that allows a dictionary attack to work very well if I choose to use any of those personal things in my passwords. Multi-domain usage basically means I'm using the same password in different applications. So if someone's able to exploit my Facebook password, there's a reasonable chance that it is also my Lancope password. I will tell everybody it is not, but if you could steal one of those passwords, maybe it works somewhere else. So do a SQL injection against that weak website and reuse the credentials that are stolen. Analog to digital conversion. This is, I won't go down a rabbit hole, but basically I have to actually touch my keyboard to put my password in. So if you have eyeballs, you can watch me do it. Or if you get, my wife just picked up a Ultra HD GoPro, and you could film me from across the room with that many pixels and record every single thing that I'm typing into the keyboard. So you can watch people put credentials in there. We saw this with skimming at ATMs. Transmission. So if I'm sending passwords across the wire, that has to happen. It's part of the way systems work. You can become a man in the middle. Cafes are great places for this, where you stand up a rogue access point that all the traffic goes through. You decrypt it in the middle and steal the passwords that way. So again, there's many options for getting those credentials, and that's there. Exploiting the endpoint. Human beings drive endpoints, and we make very bad decisions very regularly. So we'll install malware. We can be tricked into it. We'll do it. It looks like a fun game. We'll put it on or whatever. There's so many ways around that. Machines have to communicate using TCP or UDP ports, so those ports tend to be open. Things like SMB inside of enterprise networks for service sharing are open, so you can make a direct connection. Supply chain is starting to come up as machines are being built. Malware, if the supply chain is not protected, can be installed before the machine even shows up, and you unbox it. And then walk-ups. If I am an insider in whatever capacity, it's better for me not to use my own machine. Why not walk to the cubicle next to mine and use it as that individual walked away to get a cup of coffee or something. So those are insider endpoint threats. Not going to talk about statistics too much again, but one thing, this was good from Carnegie Mellon CERT. A couple of things that are relevant here. When we are looking at, so they broke down insider threats into IT sabotage, someone trying to break the network, financial gain, someone trying to steal information, and business advantage is basically, these use cases were mostly folks leaving an organization and they wanted to take their Rolodex or competitive information with them as they're leaving. So as you can imagine, 88% of these were people that had access abusing their access. It was actually the human being. They weren't using someone's stolen account. They almost always use their own credentials. And then IT sabotage, people put more thought into this because it's always an unwise thing to do. You're not getting any gain except out of rage. But anyway, it is almost always non-technical users except at IT sabotage, right? IT sabotage is the technical user, but financial gain tends to be the folks typing on keyboards, processing card information and the rest. So if you want to reduce the threat from the actual human being, you start running into civil liberties issues, but background checks, get rid of passwords altogether, use certificate-based authentication, two-factor biometrics, that kind of thing. Passwords there are problems with passwords, obviously. We also need to deal with endpoint hardening, right? You need to close those ports, do some sandboxing, and the rest. So one thing that I haven't covered yet is this idea of logging where users are. How is Ethel in Atlanta, and an hour later she's in Boston? That's not currently possible. Again, looking at data hoarding, we spoke about this in protecting crown jewels, but how much information is normally collected? In this case, this type of host normally collects 100 megs of traffic, but today, and not this, when I say this type of host, the hosts that are like it have been mathematically calculated to a norm or a baseline of 100 megs, but across the network, this host pulled down from multiple hosts 11 gigs of traffic. So we need to figure out why someone needed 11 gigs of corporate or healthcare research, whatever the type of data was. Same thing with data loss. Less than 500 megs normally leave these machines over a monitored period of time. Today, 8 gigs left the network and went somewhere to the internet. And then the last thing I wanted to hit on was is audit trails. Things are going to happen, breaches are going to happen, but if you don't want them to keep happening, you need to catch the people that are doing it, for one. Law enforcement in America specifically, but really most of the world, never stops crime from happening. They deal with crime after it happens. If I go down to the Loop in Chicago today and I knock over a liquor store, it's not going to be drop floors or lasers or things that stop me from doing it. It's going to be, folks will recognize that I did it. There will be evidence of me doing it, and I will go to jail. And so we need to bring that into the information security realm. And so The challenge we have is evidence decays very quickly inside of computers. As soon as the packet is gone, it doesn't really leave fingerprints. You either logged it and captured it, or it's gone. So you have to think about evidence collection well before an event occurs. And again, that's to make the attackers fear, because they know that evidence is being collected. The other thing is the amount of time that you collect or store that information has to be longer than it takes for you to detect there's a problem. And so, when we're dealing with data, if you steal anything else, if I was to steal a car, people would notice because there's no car there. But if I steal data, the data is still there. I stole a copy of it. So it's there are complexities in detection that don't exist in the physical realm. And so when we talk about what type of data to collect, there are trade-offs or benefits, and many of these things you're already collecting to some degree. But syslog can be collected easily and stored easily on event management solutions. PCAP is great because it gives you everything, but it's difficult to process. So when you're trying to do an analysis against it, it's very heavy. It also requires a lot of disk space, which makes it expensive to store for long times. And it's also limited in breadth. So you get very deep data in PCAP, but you can't keep it very long, and you can't get it from everywhere. But you still need it. There are places where only PCAP is going to work, where only packet capture is going to work. NetFlow is, you can potentially log every conversation in the entire organization and store it for much longer periods of time. Many Lancope customers store data for 6 months or a year of every conversation inside the network. Again, these are different areas, and you have to look at where to deploy them and the cost and return. But certainly think about this early, even before you're dealing with specific attack types. You need to have the evidence available for the investigation. So we've hit on this, but the network can essentially become the sensor. The other thing, and I know you can't really see this here, is NetFlow's metadata. So you can put any piece of data into NetFlow that can be calculated. In this example, the devices, things like firewalls, like Palo Alto firewalls, Cisco ASA firewalls, have the capability of being aware of the user credentials being used in a given conversation. So, and there's also things like integration with Cisco's Identity Services Engine or Lancope's ID box, which can correlate user to communication. So now you're not just looking at an IP address or even a MAC address. You're looking at the actual human being, or not human being, the credentials used in a given conversation. And that type of user attribution is powerful in deterrent, but it's also very powerful in investigating. So actually resolving what occurred inside of a given incident. And again, if you have that information, you can start investigations at the user level. If you have human intelligence telling you, and I was working one of these investigations yesterday in Wisconsin, where there's a problem with an actual human being, and action was being taken against that individual, and it was necessary to monitor that user's behavior, both preceding and following the action. And so there are going to be some times where you need to look at the traffic from a user perspective, and embed tools like StealthWatch have that capability. So real quick, my history with Lancope goes back to about 2001, 2002, and the company was founded in 2000 out of research that was being done at Georgia Tech around NBAD. I was at the Naval Postgraduate School at the time. There was also research being done there around network behavioral anomaly detection. So we had a close relationship. I was a customer in the early days there as well. So the whole idea, again, is we've explained it, but there are stats there you can read. Basically, from a forensic and detection perspective, is this cataloging every communication connecting it to the users and the devices, and then adding the context unique to the network. What does normal look like? Give me an idea of when something begins to deviate from that normal. Add the context also from what are the firewalls saying and the rest. It's a unique way of detecting and responding to problems. And so across the top, we have who is the actual, what credentials are a user, what application are they doing, what are they trying to do on the network, where are they geographically located, when are they doing it, and what method are they using to do that, and blowing that up to a dashboard built around those workflows. And so basically know every host on the network. As soon as we turn NetFlow on inside of StealthWatch is pretty magical, because it normally takes us 20 to 30 minutes to get StealthWatch working. We deploy a couple of devices, we'll look at it in a second, we point NetFlow at it, and so not only are we looking at the communications, but we know the host generating the communications, so we can inventory the network based upon observed conversations very quickly, and figure out who's using what service, how are they using the service. It's a pretty powerful passive way of understanding the host. Also, of course, as we've already discussed, understanding every conversation, recording it, being able to query it, if there's a problem from a security perspective or a HR perspective, compliance, being able to go back in time once you become aware, and looking at those conversations is a powerful business enabler. And this is something, my job is largely to help evangelize this and enable folks in deploying and using StealthWatch, but almost no one knows what is normal inside the network, because there's so many types of normals. How do you chop that up? And so it's a very liberating and empowering thing to know how do the MRI machines interact with, who are they actually talking to, who's using them. And so the use cases become pretty powerful, even from threat detection to network performance monitoring to even bill back across departments or customers. And then getting an alert when there's a change or a problem. StealthWatch isn't looking for one event. It's not a weird packet just happened. We put these scores on every entity, observed entity in the network, and when the cumulative behavior poses sufficient risk to the organization, we can alert the SOC. We also have some integrations for enforcement now, as far as Cisco's Identity Services Engine with 1.3 of ICE and 6.6 of StealthWatch. We can automatically quarantine hosts. We send a command over to ICE, which is a network access control solution, to reprovision that host, take away trusted employee access, and quarantine the machine until an investigation can be done. And then, of course, long-term retention. A benefit of taking in NetFlow with StealthWatch intelligently processes it, merges all of the collective intelligence about every conversation, applies it to the entity, merges and deduplicates it, so you have very succinct information when you need it. So, with that said, there is a management console. This is what the human being looks like. It's what sends out the alarms. A deployment has at least one flow collector. That's where we send the NetFlow. It's the workhorse of the solution. We typically deploy one of these per continent, even in large global deployments, and we just point NetFlow from the routers, switches, firewalls, and in areas where we want enriched NetFlow or the network can't support NetFlow export, we can use a flow sensor to create a rich IP6 output up to the flow collector. Supplement that with Cisco's Identity Services Engine, the ID1000, data coming off of Palo Alto firewalls to get user and device, or specifically credential and MAC address information, and doing correlation on that. But these devices come in physical, they come in VM versions, and most of the time we have them spun up in well under an hour, most of them in under half an hour. So that's the portfolio there. It's time, coming up on time, so let me wrap this up.